Matrices, Lecture 7.
Hi, hello everyone. For this session, we will discuss few problems on determinants. So, see the first one. So, determinant of this value is a0 plus a1x plus a2x square and so on. Then you want to find a1 value. Okay. So, for that, you have to differentiate the given determinant and put x is equals to 0. Then clearly you will get a1 value. So, here given. So now here differentiate with respect to x on both sides. So differentiate of this determinant is what? Differentiate of the first row plus differentiate of the second row plus differentiate of the third row. So that is differentiate of 1 plus x, that is 1, and differentiate of 1 plus x square. 2 into 1 plus x and 3 into 1 plus x whole square. So remaining two rows write as is, that is 1 plus x whole to the power of 4, 1 plus x whole to the power of 5, 1 plus x whole to the power of 6. So next 1 plus x whole to the power of 7, 1 plus x whole to the power of 8, 1 plus x whole to the power of 9. Okay. So plus differentiate of the second row, that is 1 plus x, 1 plus x whole square, 1 plus x whole to the power of 3. This is 4 into 1 plus x whole to the power of 3, 5 into 1 plus x whole to the power of 4, 6 into 1 plus x whole to the power of 5, and write third row as is, that is 1 plus x whole to the power of 7, 1 plus x whole to the power of 8, 1 plus x whole to the power of 9. Plus differentiate the third row. So write first two rows as is, 1 plus x, 1 plus x whole square, 1 plus x whole. So next second one, 1 plus x whole to the power of 4, 1 plus x whole to the power of 5, 1 plus x whole to the power of 6. And differentiate the third row, that is 7 into 1 plus x whole to the power of 6, 8 into 1 plus x whole to the power of 7, 9 into 1 plus x whole to the power of 8 is equals to differentiate of constant, that is 0, differentiate of a1x, that is a1 plus 2a2x and so on, and put x is equals to 0. So put x is equals to 0. So what you get here? 1, 2, next 3, next this one 1, 1, 1, 1, 1, 1. Next plus, so this is what? 1, 1, 1, next 4, 5, 6, last row 1, 1, 1. Plus this one 1, 1, 1, 1, 1, 1, 7, 8, 9 is equals to a1, that is 0. So clearly here two rows are identical. This is 0 and here also 0 and this one also 0. So clearly, so what is a1 value? 0. So option 3. So now see the second solution. Here y is equal to cos x. So given y is equal to cos x. Here yn denotes the nth derivative of the cos x. So then find this determinant. Here n is equals to 4. So we have to differentiate y as 4 times. So that is, what is y1? Differentiate of cos x minus sin x. And what is y2? Differentiate of minus sin x, that is minus cos x. And y4 is what? Differentiate of minus cos x, that is what? Sin x. And what is y5? Differentiate of sin x, that is cos x. So similarly this is equals to y6, this is y7, this is y8. Again, this is y9, this is y10, this is y11, this is y12. Now consider this determinant, that is y4, y5, y6, y7, y8, y9, y10, y11, y12. So what is y4? y4 is sin x, and y5, that is cos x, and y6 minus sin x, and y7 minus cos x, and y8, that is sin x, y9 cos x, y10 minus sin x, next y11 minus cos x, y12 sin x. So clearly both first row and third row are identical, therefore determinant of this is 0. Okay, so clearly option 1. So see the next one. With the usual notation in triangle ABC, then find this determinant. Okay, so here you know that, so what is sine rule? Small a is equals to 2r sin a. Okay. So what is sin a value? A by 2r, and similarly sin b value is b by 2r, and sin c value is c by 2r. So now substitute sin a, sin b, sin c in given determinant. So what you get? So that is 1. What is sin a? A by 2r. And here sin square a, that is a square by 4r square. Similarly 1 b by 2r, b square by 4r square, 1 c by 2r, c square by 4r square. So from the second row 1 by 2r common, from the third row 1 by 4r square common. So clearly this can be written as 1 by 8r cube. So into 1 1 1 a b c, a square b square c square. So now here c1 implies c1 minus c2, and c2 implies c2 minus c. So what you get? 1 by 8r cube into c1 minus c2, 0, a minus b, a square minus b square, 0, b minus c, b square minus c square, 1 c c. Okay. Now from the first column a minus b, from the second column b minus c is come. So this can be written as 1 by 8r cube into a minus b, b minus c square. So remaining 0, 0, 1, next 1, 1 c, next a plus b, b plus c, c. Now find this determinant. So what you get? 1 by 8r cube into a minus b into b minus c into c minus. So this is the value of given determinant. So next to see the fourth solution. Here f of theta is given, then find the range of f of theta. Here f of theta. So find this determinant. So what you get? Cos theta into 4 cos square theta minus 1. Next minus 1 into 2 cos theta plus g. So here this is 4 cos cube theta minus cos theta minus 2 cos theta. This is what? 4 cos cube theta minus 3 cos theta. So clearly f of theta is what? This is cos 3 theta. So you know that the range of cos theta is what? Minus 1 to 1. Therefore, similarly, range of cos 3 theta is minus 1 to 1. So clearly option 3. So see the fifth solution. Here A, B, C, 3 matrices are given. Then find trace of A plus trace of A into BC by 2 plus trace of A into BC square by 4 and so on infinite. So first find BC here. So because of here BC square, next one BC cube and so on. So that's why consider BC. So what is B? 3, 4, 2, 3. And what is matrix C? 3 minus 4 minus 2. So multiplying these two matrices, so what you get? 9 minus 8, 1. Here minus 12 plus 12, 0. Next to 6 minus 6, 0. Minus 8 plus 9. So you will get BC's identity matrix. So therefore BC square is I and BC cube is I and so on. Now consider this one. So therefore trace of A plus trace of A into BC by 2 plus trace of A into BC square by 4 and so this can be written as trace of A. So what is BC? I. So identity matrix with A. So multiplication of A into identity matrix. Again you get matrix A. That is trace of A by 2. So next one I square, that is identity matrix. So A into identity matrix. Again we will get matrix A. That is trace of A by 4 and so on. So you know that trace of Ka. So write as K into trace of A. So this is the one of the property of a trace. Now here this can be written as trace of A plus 1 by 2 trace of A plus 1 by 4, that is 2 square trace of A and so on. Now here trace of A is common. So what you get? 1 plus 1 by 2 plus 1 by 2 square and so on. So what is trace of A? Trace of A is 2 plus 1, that is 3. And here sum of the infinite terms are in GP. Therefore that is A by 1 minus R, 1 by 1 minus 1 by 2. So clearly this is a 6. So clearly option 1. So next to see the sixth solution. So matrix A is given and here this matrix satisfies the equation x square plus k equals to 0. So then which condition is satisfied? So here A is equals to A, B, C, D and A satisfies x square plus k is equals to 0. So that means substitute in place of x, A, that is A square plus k is equals to 0. So this k can be written as k into identity matrix. Okay. Now find A square, that is A B C D into A B C, that is A square plus k into identity matrix 1 0 0 1 is equals to 0. So now multiplying these two matrices, so what you get? A square plus BC, next first row second column, AB plus BD, so next AC plus CD, next BC plus D square, so plus K 0 0 K is equals to 0. Now see here are the corresponding elements. So what you get? A square plus BC plus K is equals to 0. See the next one here, BB common. We get B times of A plus D is equals to 0. Next one, C times of A plus D is equals to 0. Next one, BC plus D square plus K is equals to 0. So clearly from this, A square plus BC value is minus K. Here, BC plus D square value is minus K. Now here A plus D is equals to 0. So clear here, A plus D is equals to 0. Here also A plus D is equals to 0. Now, what is A square? A square is A square plus BC. So what is that? Minus K. Next AB plus BD, that is 0. Here also 0. Next BC plus D square, that is minus K. So here find determinant, that is determinant of A square is equals to minus K into minus K, that is minus K square. So therefore determinant of A is what? You get plus or minus K. So K is equals to 1 is plus determinant of A and K is equals to minus determinant of A. So clearly options all the above. So these three conditions are satisfied. The seventh solution, here A and B are different matrices satisfying A cube equal to B cube and A square B equals to B square A. So then which condition is satisfied? So given A cube is equals to B cube and A square B is equals to B square B. Now subtracting these two equations, so what do we get? A cube minus A square B is equals to B cube minus B square A. Now here A square is common, you will get A minus B, and here minus B square is common, you will get A minus B. Now this is A minus B is common, you get A square plus B square is equals to 0. So take the determinant on both sides. So that is determinant of A minus B into determinant of A square plus B square is equals to 0. So clearly either determinant of A minus B is equals to 0 or determinant of A square plus B square is equals to 0. Okay. So clearly option 4. So next to see the 8th one. So given determinants are 1, 4, 1, 3 plus 1 by 2, 4, 1 by 3, 3 plus 1 by 4, 4, 1 by 9, 3 and so on. Now find this value. So see here 1, 1 by 2, 1 by 4 and first row second element are similar. Similarly second row second element also similar. So this can be written as 1 plus 1 by 2 plus 1 by 2 square and so on. So next one 4 asterisk. So next one 1 plus 1 by 3 plus 1 by 3 square and so on. So next one 3. So clearly here sum of the infinite terms, so that are in GP. So that formula is A by 1 minus R. So A is equals to 1 and common ratio is 1 by 2. So that is 1 by 1 minus 1 by 2. So that is 2. Next here 4. And here 1 by 1 minus 1 by 3. So clearly that is what? 3 by 2. Next to 3. Now find this determinant. So what you get? 6 minus 12 by 2. This is 0. So clearly option 3. So see the ninth solution. Here the maximum and minimum values of 3 by 3 determinant whose elements are belong to 0, 1, 2, 3. Here let A is equals to any 3 by 3 matrix. Here elements are what? Given elements 0, 1, 2, 3. So for maximum value we have to write these diagonal elements are 0 and non-diagonal elements are right to maximum number. So what is maximum number? 3 only now. So write here 3. Find this determinant. So determinant of A is equals to 0. Next minus 3 into minus 9 plus 3 into 9. So clear determinant of A is what? 27 plus 27. 54. If you write these zeros as this diagonal, so that is A is equals to, so write these anti-diagonal elements as zeros and write remaining elements. So write as maximum number, that is 3. So that is 3, 3, and here 3, 3. Here also 3, 3. So in that case only you will get a minimum value of this determinant. So that is determinant of A is equals to 3 into minus 9. So minus 3 into 9. Minus 27 minus 27. Minus 9. So clearly this is minimum value. And this is maximum value. Clearly this is maximum value and this is minimum value. So option 3. So given this 7th degree polynomial is equals to this determinant, then find the values of G and H. See here, you want to find G and H. So for finding the H value, so put in place of x 0. So here first put x is equals to 0. So what you get? This all terms should be 0. You get H value only. So H is equals to what? So put the right side also 0. You get 1, 2, 0, 0, 1, 2. Next to 2, 0. So now find this determinant. That is 1 minus 2 into 0 minus 4. That is minus 4. So clearly H value is 9. Next you want to find G value. So for that differentiate the given determinant. See here, differentiate with respect to x and put x is equals to 0. Okay. So clearly what is LHS? This is 7ax power 6, x is 0. This term should be 0. And 6bx power 5. So here also you get x term, that should be 0. So clearly this all terms should be 0. And differentiate of gx, that is g. So you get LHS value g. And RHS, differentiate this determinant. So that is RHS. So differentiate of this determinant is differentiate of the first row plus differentiate of the second row plus differentiate of the third. So that is 1, 2x, next to 2x plus 1. This 2 write as is x square plus x plus 1, x square plus 2. Next, x square plus 2, x square plus x plus 1. So plus differentiate of the second row. So write first row and third row as is. So that is x plus 1, x square plus 2, x square plus x. Now differentiate of second row. 2x plus 1. So 1, 2x, this is as is. So next plus differentiate of the third row. So first two rows are as is. It is x plus 1, x square plus 2, x square plus x square plus x plus 1, x square plus 2. Next here differentiate of third row, that is 2x plus 1. Now put x is equals to 0. So what do you get? 1 0 1. This is 0 1 2. Next one 2 0. So plus this one 1 2 0. Next 1 1 0. Next one, this is 2 0 1. Plus here also put x is equals to 0. What do you get? 1 2 0. Next 0 1 2. Next 0 1 1. So now find this determinant. So that is what? This is 1 minus 0 plus 1 into minus 2. Okay. Next this one 1 minus 2 into 1 plus 0. Next plus this one 1 into 1 minus 2 minus 1 minus 2 into 0 minus 0. Next one 0. So plus 1 minus 1 get cancelled. Now this is minus 2 plus 1 minus 2. So minus 4 plus 1. You will get minus 3. Therefore, what is g value? G is equal to minus 3 and h is equals to 9. So clearly option 4. So see the next question. Here x power a, y power b is e power m, x power c, y power d is e power n, and delta 1, delta 2, delta 3 is given. Then the values of x and y are. So given x power a, y power b is equal to e to the power of m, x power c, y to the power of d is equal to e to the power of m. Now apply log on both sides. Log of x to the power of a, y to the power of b is equal to log e to the power of c. And here log x to the power of c, y to the power of d is equal to log e to the power of m. Now clear this is what? Log a plus log e. It in the form of log ab, so write as log a plus log b. That is a log x plus b log y is equals to m. And here also log ab formula, that is log x power c plus log y power d. So log x power c write as c log x plus d log y is equals to n. Now here, what is A matrix in this part? A, B, C, D. So now find this determinant, that is determinant of A is equals to determinant of A, B, C, that is given delta 3. And what is delta 1? So replace first column with constant matrix, that is M, N, B, D. That is also given. And delta 2 is what? Replace second column with a constant matrix, that is A, C, M. The solutions are here log x is equals to what? Delta 1 by delta 3. And log y is equals to delta 2 by delta 3. So here what is x value? E power delta 1 by delta 3, and y value e power delta 2 by delta 3. So by Kramer's rule, so these are the both x and y values. So clearly option 4. Next to see the 12th solution. Here matrix f of x is given, then find integration minus a to a determinant of f of x dx is what. So one condition is there, integration of minus a to a f of x dx. So it is equals to 0. F of x is odd. 2 times of 0 to a f of x dx. Here in this case f of x is even. If the given function is odd function, so what is odd function? F of minus x is equals to minus f of x, then f of x is odd function. If f of minus x is equals to f of x, in that case f of x is even. If f of x is odd, then this value is 0. If f of x is even, in that case this value is 2 times of 0 to a f of x dx. So first to find this function is odd or even. See here, determinant of f of x. So write as determinant of sin x, cosec x, tan x, and secant x, x sin x, x tan x, x square minus 1, cos x, x square plus 1. Now find f of minus x, sin of minus x, minus sin x. This one cosec of minus x, minus cosec x. Tan of minus x, minus tan. Secant of minus x, that is secant x. Minus x, sin of minus x. You will get x sin x. And here x tan x. Okay. Next here x replace minus x. You will get x square minus 1. Cos of minus x, that is cos x. Here also x square plus. So now here from first row minus is common. So what you get? Minus of sin x, cosec x, tan x, and secant x, x sin x, x tan x, and x square minus 1, cos x, x square plus 1. What is this function? F of x, that is mod f of. So clearly what is the determinant of f of x? So clearly given function is odd function. So therefore given function, that is determinant of f of x is odd. So therefore integration of minus a to a determinant of f of x dx value is 0. So clearly option 4. So for next session we will discuss more problems.